inequalities, some more examples. The more you practice it, the more you'll get the hang of it. Although you're not quite sure what everything means, all you need to find are your answers. So I want to tell you that if you're in a sum, if in a question paper, and that question 1 comes that says solve for x, solve for x, solve for x, with everything you've done all together, you must then identify that this is the sum with inequalities. And it can somewhere else also appear in other sums on a different place. But the moment you get to the inequality sign, you've got to know that there's either linear, which you've done in grade 10, and now there's also quadratic. So if there's quadratic, you should think this whole little thingy here that I've talked about, that whole method that's coming out there. So the steps are, first you must get 0 to the one side. I don't need to let you do that with this one. If there was the 12 on that side, you just bring it to this side. But then we need to
divide by -1.
okay, then I've got -1. Why? Because you want to factorize. Get 0 and factorize. So why would I like to get rid of the -2? Because then it's going to be easier for my James Bond or quadratic trinomial technique. So it's going to be x squared if I divide by -2. Implying immediately that that sign is going to swap. The moment that you divide by a negative, I told you yesterday, why do we swap the sign?
So that's true.
Because otherwise it's not true. It's like when we say -2 is smaller than 3, then if we time both sides by a negative to make it true, that's why we have to swap the sign. Now, not because we want to make it as difficult as possible and make something interesting happen, it's to make it true. So when you divide the whole thing by -2, then this will be not working. Because why do I divide by -2, not just by -1? Because the negative is the, not -1. Because the negative is not the 2 is not the problem, the negative is the problem. So you can just divide by the negative, and then this will become positive and negative. I think you're thinking about completing the square, where this has to be a 1. You don't have to divide by 2. Just divide by the negative, because I always want this to be positive for my technique. Then the factors of 2 and the factors of 12 is 1 times 2 and
2 times 3.
No. Help. No. Come guys, help me. 12 and 2 is not getting me to 5. Excuse me. Thank you. So, if I want factors, I'm searching until I find for 1 times 2, 1 times 12, 2 times 6, 3 times 4, swap them. 2 times 4 then was 8, and 1 times 3 is 3. And I need to find positive 5. So it's plus, minus. And if you've got the new calculator, so much better, it'll just give you the factors. So those factors are x plus 4 and 2x minus 3. So that now, if it had been an equation, you were done. Answer x is equal to -4, x is equal to 3 over 2. And if you're still battling doing that one shot, then you've got to say 2x minus 3 equals 0, 2x equals 3, x is equal to 3 over 2. But I'd like you to very quickly get to that method that you've got the answers. But those are not my answers, those are my critical values, which are -4 and positive 3 over 2. And then what do you do with it? You place it on a number line. So the number line, logically, my -4 is left from 3 over 2. And then our technique is, we start top right, go through your critical value and turn back again. And then it won't turn back again because there's not another value. Alright, which confers with the fact that this is actually a quadratic expression, which is a parabola. And in a parabola, I then go and I say bigger than 0, that will be there, as well as there. And I colour in, right? So that my solution is x is
less than
less than or equal to -4,
or
or
x is greater
or equal to 3 over
2.
2. And that's my answer. And if you want to go test it, then you've got either -5, for instance, that you place into the answers, work it out and see that the answer will be less than 0. If it's 3 over 2, you put it in there and you work it out and the answer will be less than 0. If it's anything else in between here, like for instance 0, won't work. Place 0 there, it's 0, it's 0. So 12 is less than 0. Why doesn't it work? Because I took a value for x that I shouldn't. There's lots of answers represented here, and the answers that are correct is anything less or bigger than. The including signs as well. Now this is a typical grade 12 sum. In a matric paper, and it counts about 3 marks. 3 or 4. Typically, matric end exam November, that's what they get. All the other stuff that I'm teaching you sometimes gets asked on a little twitch here and there. But this is in general what's happening. The main mistake that kids make is they want to go say, why can't I just say x plus 4 is bigger than, and that is bigger than. And then both of them would be bigger than, and do you see that this is less? So that's why you need this technique to show you, because it's not always just bigger than, bigger than. Or if that was smaller, you put both smaller than, it doesn't work. You've got to use this technique. Alright, let's go a little bit more difficult again. I never even checked it, but let's just go through the checkpoints. If I have the factors, they must both be in descending powers of x. So x has to be in the front and the number at the back, and it must be positive. So everything was fine. Bouncing didn't happen here as well. So all of those list of things that you're going to check through, nothing of that happened. For this one again, just getting into the nick of things, if I want to find the solution, how many critical values do I have? Because everything's been done. 0 and factors. So the critical values are
2 and -1.
2, yes, -1, and
0.
and 0. Excellent. And that's not according to scale. How many factors are here? 3 factors. X times the bracket times the bracket. And what are critical values? When will one of them be 0? When will this be 0? If x is -1. When will this be 0 if x is 2? When will x be 0 if x is 0? That is the critical value for just x. So if 3 things are multiplied and the answer is 0, one of them has to be 0, and that can be then if x is 0. Then this was 0 and everything is then 0 because multiplied by 0 is 0. So I've got 3. Are they all in descending order? Yep. Are they all positive? Say I had a negative x there. What would you have to do first? Change it to a plus by dividing by a negative, and then this would swap it round, which implies that if I'm here, I have to color in top, bottom, wherever. Right, so I'm starting at the top. Right, according to my method, descending powers, it has to be positive. If there's a bouncing, is there a bouncing here? No, because there's not 2 of those factors that are the same. If this was an x squared, there was a bounce. Because it's the same factor twice. Are you with me?
Yes.
Same factor twice. Then it would have been bouncing at 0. Now we start at the top right, goes through, goes through, goes through. Remember, it goes up to infinity, goes down to infinity. It's actually matric cubic graphs, but it's just a technique that nobody gives you marks for that helps you to get to your solution. Now, we color in. We color in at the bottom, less than, smaller than. So we go at the bottom. Where's that? Over here, between the line and the curve. There's no curve here, so I can't color in here. Between the line and the curve, and again here, there's no curve, so I can't color in there as well. that represents my solution. Are those critical values my points of importance? Are they colored in or not? No. So they are open intervals, all of them, because it's open. Usually if it's open, everyone is open. If it's included, then everyone is colored in. But then you've got to check if it's fractions, you can't have a 0 at the bottom. So it's details every time. This now represents my answer. I'm going to write the answer down, which is x is less than negative 1. That's the one part. The other part, x is between. Do you hear me saying that every time? X is between with two smaller than signs. Smaller one on the left, bigger one on the right, and they are both excluded. Because of that, no marks. The marks go 1, 2, 3. And that's it. There was nothing strange to that sum as well, just to get you back into the hang of it from yesterday. Right. Especially you would have seen, I keep giving it to you like this, because I won't ask you to factorize stuff like this, because you can't yet. If you time all of this out, it'll be cubic graphs, which you can't factorize yet. Okay? So if it's given to you like this, then fantastic. 0 and all factors, and you're just going on with our method. So you see that little smaller than or bigger than sign, and what goes through your brain is that little technique of ours. So we need our critical values. There are 4 factors here. Right? What do you see? There's one that's going to bounce. And when you start writing down the critical values, you'll get it anyway. So the critical values are negative 2, positive 1, aha, negative 2 again, it's going to bounce there, and 3. So on our sketch, in order, negative 2, 1, 3, just make sure it's in order on the number line. You start top right hand, and to make sure for myself that I will not go through there, I'll bounce there. It doesn't matter whether I come from the top or come from the bottom, it has to bounce there. If I was coming over here, it bounces back. If I was coming down there, it will bounce back. Are you with me? Like those games we play. So we start top right, we go through, and this time it's bouncing right back here. Alright, looks terrible, because it's actually more than a cubic graph, it's a 4th power graph. Alright, which is not syllabus, but this technique works always. Always. So when I look at the sum, where must I colour in now? Where must I colour in? Smaller than is at the bottom. That's it, eh? And then what do I do at the critical value points? You make them closed. So closed, closed, closed. Not with the 3, excellent guys. Why not at the 3? This says go include all of them, but this is not me. I'm at the bottom, so that has to be excluded. This in. So if it says in, usually we want to include all of them, but just check. Isn't there something illegal, a red light, that I cannot abide by? So what's the represented answer?
X is between 1.
X is between 1 and 3. Included, definitely visible, included, and definitely visible, excluded. And that's it. What? Yeah, or? Or? Specifically just that one little answer. There's hundreds and millions and trillions of answers there between those two. But here's one specific answer as well, and you might have missed it. So go back to the sum. If you do put a -2 there, what's going to happen? It's going to be 0. So it doesn't matter what happens to the rest of the sum. 0 times whatever divided by something is 0 less or equal to 0. So it works. For that one specific answer, and there's a whole interval of answers as well. Interesting? Right, wake up. So for this one, it has to be a small answer because I left a small space. I'm asking, what will be the answer for that one? X plus 2x minus 2. Can't factorize this. Can't factorize this. Because it's not difference of squares, it's the sum. If you do this,
No
x
solution.
squared,
No solution.
exactly wrong. It's anything. It's anything. But man, now where's my technique? Because I want to get 0 and I want to factorize, but there are no factors. If you want to try and solve it this way, be careful because you cannot do just square root on either side. That's fine. But I'm asking you, what values of x, if I fill them in there, will be bigger than negative 4? Everything. It doesn't have to be negative 3, it doesn't have to be negative 2 because it won't. But anything squared will be
Positive.
positive. So anything squared will be positive, so anything will be bigger than negative 4. So x. So why do I throw this in here? Because that's what happens in an exam. I ask you something and you're thinking, oh, it has to be that technique. Then you go 0, you go factor. Factors don't want to work. So if the question had asked me, this question. Let's make it question 8a. What would be? No solution. Because a square can't be less than, can't be negative in other words, less than 0. Funny thinking, caps on. Alright, let's get back to the normal stuff again. So if I give you one like this, what's wrong with it? That's not in descending. What is you? For my technique to work for you, you've got to change it into x minus 2. I think we've done quite a few now and it's enough. And then when you do that, what's happening here?
Sign change.
Because you're timing with a negative to make it right. Don't I put the minus on the outside? You don't want that. You want everything to be positive. If you put a minus on the outside, there's another minus that's probably bothering you. Everything's got to be positive and everything's got to be descending. If you do that, you just have to change the sign. Are you with me? Then my critical values are 2, 1, negative 3. Where do I start? Negative 3, 1, 2. Write it down for yourself. It makes life easier. So that you can go and order them in the correct order. Start at the top right. Only if you followed all those rules. No bouncy bounce here. Okay. So we go top right and through and through and through. And we're colouring in at the top. Don't look at the original sign. At the top, where you changed it to be perfect and sharp. That's where you use the bigger than sign. So it's got to be there as well as there. Colour in. Everything right? No? What not? The 1 must be excluded. So excluded but in and in. So to write down this, do you see that this is a representation of your answer? It'll be the x's are between negative 3 and 1, in, out, or x is bigger than or equal to 2, 3 marks. Probably not a mark for this because there are other techniques as well. I just want the answers. Right. Alright, technique. Factorize, it's not necessary. What is the critical value?
Negative.
Just negative 2. I'm going to tell you now this is a silly sum. You're going to tell me now, oh man. Okay. Critical value negative 2. Only one of them.
So it counts.
So now I still start top right and I go back. Where? It doesn't come back. There is only one critical value. Where do I colour in? At the bottom. Where does this go? To infinity. So x is, and do I colour in or not? Any reason why I don't colour in? Okay, now tell me, man, that was stupid. Tell me, man, that was stupid.
Man, that was stupid.
And then take it to a cross. You see it? But I like to show you that it still works. If you say that this is a factor and the critical value is, and you sketch it and there's only one critical value, you always start top right. Actually, I should make this more straight line, because it is a straight line. You'll go top right until forever, and there it is. But who would do that? If I asked you this question, you just take it to a cross and that's it. Okay, I'm trying to get your brain into, don't overthink things. Okay, let's go for this one. Critical values? -3 and 0. And it bounces because there's 2 of them. So it bounces and it goes right back, bouncing down again. Well, not bouncing, going down again. And I'm coloring in at the bottom. I want to include it. Sorry, let me change my own sum. Including it, so I can include all of them, right? No problem with X's at the bottom. So include, and I'm coloring in at the bottom, which is only there. So the solution again is X's.
X is less than.
Less or equal to -3.
Or X is equal to
Precisely equal to 0. Just that one specific solution, and there's a whole bunch of them. But they're both.